Hello everyone, I am ANITHA KRUPANIDHI, Assistant Professor of Chemistry at Marri Reddy Institute of Technology and Management. So in the previous session, we have discussed about natural rubber and its vulcanization. Now today, we'll discuss one more topic, that is conducting polymers from polymeric materials chapter. So today we'll see about conducting polymers. What is meant by conducting polymers, their definitions, and then characteristics and classification of conducting polymers. Now first we'll see what is meant by what are conducting polymers. Okay, so what are conducting polymers? Conducting polymers means the polymers which conduct electricity, right? So the polymers which conduct electricity are known as conducting polymers. So in general, the polymers do not conduct electricity. Okay, so why? Because these polymers are insulators. Polymers are insulators. Insulators means they do not conduct electricity. Why? Because they do not conduct electricity means the movement of electrons from one point to another point does not takes place in the insulators. So our polymers are insulated, that's why they do not conduct electricity. But what are the special conditions of the polymers which make them to conduct the electricity? Okay, so now we'll see what are the special conditions or the special characteristics of polymers which conduct the electricity. So if the polymers contain in the backbone of the polymer chain, if it contains any conjugated system. What is meant by conjugated system? If the polymeric backbone of the polymer, it contains the alternate double bonds, then it is called as a conjugated system. And in this conjugated system or the aromatic system, so in these two, if it contains aromatic rings also, they conduct the electricity. Clear? So now it is about the conducting polymers. Now we'll see what are the main characteristics of conducting polymers. So the polymers which conduct electricity are called conducting polymers, and how these conducting polymers conduct electricity means due to the presence of unsaturation. What is meant by unsaturation means? Unsaturation means it is the presence of double bonds or the presence of externally added ingredients in them. And next, conducting polymers show excellent chemical thermal stability due to low hydrogen content and aromatic structure. Okay, and these conducting polymers they are insoluble in many common solvents. These are the few characteristics of conducting polymers. Now we'll see about what is the classification of conducting polymers. In this classification of conducting polymers, one is it is classified into two types. One is intrinsically conducting polymers and extrinsically conducting polymers. So here, what is meant by intrinsic conducting polymers? It is written as ICP, and it is written as extrinsically conducting polymers. It is ECP. And these ICP polymers, that is intrinsically conducting polymers, once again classified into conjugated conducting polymers and doped conducting polymers. Okay, conjugated conducting polymers and doped conducting polymers. And in the extrinsic conducting polymers, it is also of two types. One is polymers with conducting elements. That means just the conducting elements will be filled in the polymer. That is called as polymers conducting elements filled. And next one, polymers conducting blends. Which is also known as blended conducting polymers. So now in this session, we will see about what is the classification of conducting polymers. All these classes we will see now. First one, what is meant by intrinsic conducting polymer? Okay, so intrinsic conducting polymer means what? Intrinsically, that means within the polymer, it conducts the electricity. Because of what reason? It conducts electricity. So these polymers are characterized by the conjugation of the double bonds present in the structure. What is meant by conjugation? Conjugation means, suppose here it is the long chain of the polymers. Now, but it contains a single bond and then double bond and then single bond and then double bond, like this. Alternate double bonds are present in the system or in the chain. That is called as a conjugation. Alternate of double bonds alternate double bonds are present in the backbone of the polymer, then it is responsible, because of the presence of alternate double bonds, it is responsible for the conductance. Okay, so conductance means which allow the movement of electrons from one point to another point, that is called as the conductance. Okay, now these intrinsic conducting polymers are of two types. These are of two types. Now we will see these two. First one is conjugation. So conjugation means, just now I said that is the alternate double bonds. Because of the alternate double bonds, what is the mechanism taking place in these conducting polymers, we will see. So here it is a polymer in which the backbone contains delocalized electron pair. Okay, so these are associated groups, or it consists of delocalized electron pair, and such polymers are essentially contain conjugated pi electrons. Okay, so here conjugated pi electrons means how it will be in the picture, you can see. So it is the alternate double bonds. Here it is alternate double bonds. Here pi bond, in the sense it is not exactly like a bond, but it is like an electron cloud. Okay, so electron cloud in the sense how it will be between the two carbons. It is like an electron. That means pi electron cloud, that is pi orbital. One orbital is present which contains an unpaired electron. Okay, so which contains an unpaired electron. So here like this, all the orbitals like this at each carbon, these unpaired, the unhybridized pz orbital is present. Okay, so that is called as a conjugated pi electrons are present in the polymeric chain, and because of this extra electron, because of this free electron, it moves through the chain. Okay, it moves through the chain. That's why so that because of that it conducts the electricity. And now here if you see these orbitals, just now we have seen that like this alternate double bonds are there. Like this alternate double bonds are there, and at each pi electron, each bond, each carbon is containing the pi electron cloud. Okay, so it contains an unpaired electron. It contains an unpaired electron. Because of these electrons or these pi electron cloud, it overlap with each other. Okay, so like this overlapping of the one p orbital of one carbon atom, and the another with the another p orbital of the another carbon atom takes place. Okay, so because of this overlapping, what happens is, because of this overlapping of the orbitals, it leads to the formation of valence band and conduction band. Okay, so because of the overlapping of the orbitals in the polymeric chain, it leads to the formation of valence band and the conduction band. Okay, so valence band, conduction band means we may have an idea on this one. Valence band, conduction band, between these two a gap is present. Between these two a gap is present. This gap is called as Fermi energy gap. Okay, so how the formation of this valence band, conduction band with the Fermi energy gap is formed means because of the overlapping of orbitals. How these overlapping of orbitals are taking place, students? So here unpaired electron is there because of the pi electron cloud. Okay, so these pi electron cloud and unpaired electron is present. They overlap with the another carbon atom of the pi electron cloud. Because of this, what is forming here? It is forming the valence band and conduction band, which were separated by the Fermi energy gap. The gap present between these two valence band and conduction bands, it is called as a Fermi energy gap. Okay, so next the presence of conjugated pi electron in a polymer. Because of the presence of this conjugated pi electron in the polymeric chain, it causes what? It increases the conductivity. Okay, so it increases the conductivity. So how this conductivity is increased here means, so it increases the conductivity to a larger extent. Why? Because when we give any external source of electrons, all these electrons, it starts moving. Okay, it starts moving through the entire chain, so that conductivity of the polymer will be increased. So here what are the examples? Examples like polyacetylene, polyquinoline, polyaniline, and apart from these ring compounds, all the conjugated systems, these are the examples for the intrinsic conducting polymers with conjugation. Now the next one we'll see what is meant by doped conducting polymers. Okay, so what is meant by doped conducting polymer? Here first we have to know what is meant by doping. So what is meant by doping here? These are prepared from the charge transfer agent either in gas phase or in the liquid phase. Okay, so these doping means any reagent will be added. That means the polymer has to go either oxidation or reduction. So if it undergoes either oxidation or reduction, then a electron can be added or the electron can be removed, right? So because of this, what happens? Charge transfer takes place. Charge transfer takes place. Charge means what charge it is? Either positive charge or negative charge. Okay, so here charge means either positive charge or the negative charge. This charge transfer has to take place. How this charge transfer takes place means because by doing the oxidation or reduction. Okay, so how the charge is introduced in the polymeric chain? Either by oxidation or reduction. Okay, so how we can do this oxidation or reduction to the polymer means because the polymer, this conducting polymers, they have the low ionization potential but high electron affinity. Because of these two properties, we can do either oxidation or the reduction to the conducting polymeric chain. Okay, so this intrinsic conducting polymers can be made more conductive by creating either positive site or the negative site. How these positive and negative sites can be created in the polymeric chain? Okay, so how these positive negative charges can be created? By doing oxidation or reduction. So how we can do oxidation means by adding, because by adding here there are two types of doping, that is oxidative doping and reductive doping. Now we'll see how we can do this oxidation or the reduction to this polymeric chain. Okay, now we'll see this one. These are of two types. Yes, here we can see first one is p doping. What is meant by p-doping here? It is creating a positive charge. Just now we have discussed what is meant by doping. These charges, positive or negative charges, can be introduced in the polymeric chain. So how we can do those two? Now we are discussing. Okay, so here it is. First one is the p-doping. What is meant by p-doping here? By doing oxidation. So when you add a Lewis acid, okay, when we add a Lewis acid to the polymeric chain, then it is called as oxidative doping. So it is called as oxidation. How can we do oxidation to the conducting polymers? Means by adding the Lewis acid. So if we add the Lewis acidic solutions or the iodine, bromine or naphthylamine, and because of these, what happens? It loss of electrons takes place from the polymeric chain. Okay, so here loss of electrons takes place, so that we can tell that it is the this polymeric chain is oxidized. So when we add this Lewis acidic solution to the conducting polymer, it creates positive sites. Okay, so for example, just we'll see the example. So for example, it is an conjugated system or the polyacetylene. So here each carbon is containing what? Each carbon is containing this pi electron cloud. Okay, so because of oxidation, we have created a positive site here. Okay, so we have created a positive site like this. If any positive site is there, these are the unhybridized pz orbital, right? It is containing an unpaired electron. So these electrons, and from external source also we are supplying the electron or the current. Okay, so like this electrons are supplying. Whenever these electrons, it reaches this first one, this electron again jumps here, like this movement of the electron takes place. Okay, so whenever the positive sites are created, these unpaired electrons, they move fast. Okay, so they move fast to reach the positive charge. Okay, to reach the positive charge here. So that's why, because of this movement of the electrons or the charges here in the conducting polymer, it conducts the electricity. So that's why it is called as p-doping. Doping in the sense we are adding or removing any other external ingredient. So here we have created which charge here? Positive charge. Okay, so we have created a positive charge here, and that's why it is called as a p-doping. P means here here it is positive. Clear? So here it is a positive charge is created. That's why it is called as a p doping. Now next one, the second one, we will see about n doping. What is meant by n doping? We have to create a negative charge in the conducting polymeric chain. Okay, so creating a negative charge on polymeric backbone. How can we create a negative charge in the polymeric backbone? By reduction. Okay, so how can we do the reduction? Means by adding the Lewis base. So Lewis base solution, basic solutions, when we add to the polymeric chain, then what happens? Reduction takes place, that is gaining of electrons takes place. And so that because of gaining of electron, that negative charge will be created in the polymeric chain, right? So because of that negative charge and the unpaired electrons, this movement of these charges and the electrons, because of negative charge, it conducts the electricity. That's why it is called as n doping. Clear? So what it is called as? It is the, because what is meant by n here? Negative. Because of negative charge it is conducting electricity, and p doping means because of positive charge it is conducting the electricity. Clear? Yes. This is about the doped conducting polymers. Now the second one here, our classification is two types. One is intrinsic conducting polymers and the extrinsic conducting polymers, right? So here extrinsic conducting polymers. What is meant by extrinsic conducting polymers? So these are the conducting polymers that owe their conductivity due to the presence of externally added ingredients, right? So externally added ingredients in them, extrinsic, it is called as extrinsically conducting polymers. If you take the intrinsic conducting polymer within the polymeric chain, because of the alternate double bonds within the polymeric chain only, it is the movement is taking place, and if any problem occurs to the polymer, with the polymer only we have to rectify. So that's why it is called as intrinsic conducting polymer. But here it is the extrinsic conducting polymers, means with another material, anything we will add to the plastic to our polymer. Okay, so that is called as extrinsic conducting polymer. Now this extrinsic conducting polymer also two types. First one we'll see the conducting element filled polymer. So here just see the heading, see the side heading and understand the meaning. Conducting element filled polymers. Conducting element filled. Okay, so what we are filling here, we are taking the polymer. Just understand our heading first. So what is meant? It is the polymer. Okay, polymer we have taken. Then what we are doing? We are filling this polymer with a conducting element. Okay, with a conducting element. Our polymer does not conduct electricity. Okay, so now this polymer we have taken, it is not conducting electricity. But in this polymer, what we are doing here? Minimum concentration of the conductive filler, like any metallic fibers. Okay, so these are added. So to this polymeric chain, what we are filling here and there in the polymeric chain, just we are filling. Okay, so just we are filling the filling what? Conducting element. So when we supply the external source, that is the electricity, when we supply the electric source, then what happens? What we have filled the elements like metallic fibers, right? So those metallic fibers or those fillers, it passes the electrons and it conducts the electricity. Okay, so here in this case the polymer acts as insulator only. But what is the use of polymer here? Means just it acts as a binder. Okay, what you are filling the conducting elements, all those elements it holds. Okay, that means our polymer just it acts as a binder here. So now here see the sentence, students. Polymer acts as binder to hold conducting elements together in the solid entity. That means the place. Okay, so the minimum concentration, very minimum concentration of this conducting elements we are filling here, or it is added, so that polymer starts conducting. Okay, so because of those conducting elements filled, because of that it starts conducting. Clear? The example is the carbon black. It is most preferred filler as it has high surface area. as it has high surface area, more porosity and more filamentous property. This is the best example, that is the carbon black. Okay, and the next we'll see the last one in the classification, that is blended conducting polymers. So blended conducting polymers means what? In general, we know the meaning of the blending. Okay, so in the what is the general meaning of blending? It is nothing but the mixing, right? So here blended conducting polymers means we are mixing, or we are adding the conventional polymer with a conducting polymer. So it is a conventional polymer means just a normal polymer we have taken, it is not conducting the electricity, but what we are doing, just we are adding or the mixing the conducting polymer. Conducting polymer is mixed with our normal polymer, that is conventional polymer. Both are mixing with each other. That's why it is named as blended conducting polymers. Okay, so such polymers can be easily processed and they have the better physical, chemical and mechanical properties. The example is the 40% of polypyrrole in a conventional polymer. It gives higher impact strength. Okay, so this is about the classification of conducting polymers. And so in this session we have discussed about what is meant by conducting polymer, how it conducts the electricity. Okay, so how it conducts electricity because of the presence of the conjugated system, that is the alternate double bonded system. Okay, so next, what are the different classifications of these conducting polymers? Intrinsic, extrinsic, and those subtypes we have discussed, and these are the few references for this topic. And I hope this video is helpful to you. Thank you.